We're supposed to use the appropriate limit laws and theorems to determine if determine the limit of the sequence or show that it diverges. So this is a sequence of numbers. We could plug in n equals 1, see what it evaluates to be. Plug in n equals 2, see what the next value in the sequence is. And that could give us an idea of whether it's increasing or decreasing, or we could just apply calculus and find out what is the sequence going to be as we approach the infinity term. Okay, the term that doesn't exist, but as we get bigger and bigger. So we're looking to evaluate this limit. So this should bring us back to our first few days in calculus, maybe our first couple weeks in calculus. When you're trying to evaluate a limit, of a polynomial, okay, of a polynomial in the numerator, a polynomial in the denominator, the highest power is what dictates the end behavior of that polynomial, right? If one power is bigger than the other, then the power that's bigger is going to eventually win out over infinity. But see how the powers match? That means these portions of the term, the n squared part, going to really dictate the behavior, and this stuff isn't going to matter. Okay, the minus 5 over here, the plus n plus 2 isn't going to matter. So this limit is 5 over 2. Okay, and again, that just comes from considering. Okay, so back when we considered horizontal asymptotes, if you remember that discussion about when the powers are the same thing here. This sequence is going to eventually approach 5 over 2. So it looks like that's all we had to do for this problem. The limit of this sequence, it does converge, and the sequence converges to 5 over 2.